This course module covers the technical fundamentals of the laser level transmitter. After completing this module, you will be able to understand the basic principles of level measurement, identify what technologies are used for level measurement, recognize the key features of the laser level transmitter, understand the advantages of laser level transmitters over other technologies, evaluate possible applications for the laser level transmitter. Many industries store and transport the materials they use during production. These materials may be the raw materials, interim, or the final product. Wherever materials are stored, some form of level measurement is usually needed to monitor and control how full the storage vessel is. Raw and processed granular solids are stored in silos and hoppers or on stockpiles. They're transported along conveyor belts from one part of a plant to another while being blended, crushed, melted, or otherwise processed. In contrast, liquids are stored in tanks and transported through pipes. Level measuring instruments that work on liquids may not be suitable for use on granular solid materials. For example, differential pressure transmitters only work with liquids, while a plumb bob instrument only works on granular solid materials. There are many different types of instrument that measure level, depending upon the type of material, the type of vessel, and the customer's requirements. These instruments can be categorized in three ways. Firstly, do they measure the level of liquids, granular solids, or both? Next, does the instrument make contact with the material or not? Finally, does the instrument give an output that changes at a particular level, or does it provide a continuous level reading? Different level measuring products can be viewed according to the table shown. In the bottom left quadrant are the single-point contact devices, such as capacitance probes, vibrating fork switches, paddle wheel switches, and mechanical point floats. In the top left quadrant, the plumb bob instrument is typical of contact devices that give a continuous level reading. The bottom right quadrant contains single-point non-contact devices that give a single switch output without touching the material. The top right quadrant shows common non-contact technologies: laser level transmitters, ultrasonic transmitters, open-air radar, and nuclear devices. When dealing with certain types of material, non-contact level measuring instruments are more reliable. This is especially true if the material being measured could cause damage if it came into contact with the instrument. Also, contact-type instruments that rely on a wire touching or penetrating the material surface can fail if the wire becomes buried or snaps under the material load. For certain materials, non-contact is preferred to prevent any risk of contamination. When dealing with liquids, the use of a non-contact type of level measuring instrument provides a more reliable reading and avoids problems of contamination. This is especially important if the material being measured could cause damage if it came into contact with the instrument. Contact tap instruments can corrode when in contact with certain liquids. Extremely viscous liquids are very difficult to measure with a contact type level measurement instrument. Depending upon the requirements of the system, a single-point device like a capacitance probe that has a switching output may be appropriate. Alternatively, the level inside the vessel can be measured continuously with a level measuring instrument, such as the laser level transmitter. The laser level transmitters are a non-contact continuous level measuring instrument. They're designed specifically for granular solid materials and liquids, except completely clear liquids. Based on laser technology, the laser level transmitters can measure the level of almost any kind of bulk solid material stored in silos, chutes, and hoppers. They can also measure the level of most liquids stored in tanks, reservoirs, wells, and channels. The laser level transmitter is mounted at the top of the vessel, pointing downwards. In order to measure the level of material, the laser level transmitter sends a short flash of light down into the vessel. This light hits the surface, and some of it reflects back to the instrument, where it's detected by a sensitive optical receiver. The time it takes for the light to travel to the surface and back to the instrument is directly proportional to the distance between the instrument and the surface. Using a simple calculation that incorporates the height of the vessel, the laser level transmitters can work out how full the vessel is. The light that is transmitted from the laser level transmitters comes from a semiconductor laser, and it has important characteristics that give the laser level transmitters performance advantages over other technologies. These advantages will be described in more detail in the slides that follow. As mentioned previously, level measurement is achieved by measuring the time of flight of the light going to the target and back. The measurement is last bounce, so partial reflections of dust or fog are ignored. Light is emitted by a small semiconductor laser and focused into a narrow beam. Beam divergence is less than 0.3 degrees. The measuring laser is invisible to the naked eye, wavelength of 905 nanometers, and does not present any safety risk. Class 1M laser. Most surfaces will have diffuse reflectance, and therefore at least some of the light from the laser is always returned to the detector. It is diffuse reflectance that allows the laser level transmitter to measure the distance to granular materials that present a cone-up or cone-down surface. This is a unique advantage of the laser level transmitter. Certain surfaces will have specular reflectance, and therefore can only be measured if the beam of the laser level transmitter is perpendicular to the surface. Surfaces that have specular reflection are mirrors and most liquids. Lasers are classified according to their safety, and the laser level transmitter uses the highest safety rating for its invisible measuring beam. This Class 1M laser sends out very low energy pulses that are totally harmless, even if you look directly into the beam. Class 1M devices are considered eye-safe and cannot lead to eye injury unless an optical instrument that focuses down the energy is used. Do not view the laser directly with optical instruments like binoculars, telescopes, or magnifying lenses. The aiming laser is visible to the human eye. This laser is rated Class 3R, which makes it bright and easy to see, but should not be looked into directly. This laser only works at installation and after a restart for a duration of 2 minutes to allow positioning of the laser level transmitter, and can be turned off completely. One of the characteristics of lasers is that the light beam is narrow with virtually no divergence. This means that the laser level transmitters can measure in tight locations. The laser level transmitter is capable of measuring the level of a surface at any angle. The laser level transmitter can be configured to ignore sudden changes, such as occurs when a rock interrupts the beam. Unlike competitive technologies, the light reflected back from a granular solid surface does not alter its characteristics if the surface is at an angle. This means that the laser level transmitter is immune to changes in the settling angle or the angle of repose of the material. In comparison, radar and ultrasonic devices with their longer wavelength and wide beam angle are adversely influenced by the angle that the surface presents to the instrument. The signal is reflected by the surface like a mirror and will return at a different angle. The radar or ultrasonic transmitter will not receive a clear return signal. Another characteristic of the laser light used in the laser level transmitter is that once it hits a solid surface, it sends a single return signal back to the optical receiver. This is quite different from the return signals found in other non-contact level measuring technologies where multiple return signals or echoes often occur. These echoes can make it impossible to get a reading of the material level. Ultrasonic and radar level transmitters have difficulties reading to the bottom of narrow vessels. When the level gets too low, they give false readings. The same problem can occur if there is a restriction in the vessel, or if the ultrasonic or radar transmitter is installed near the vessel wall. Laser level transmitters can accurately read the level past any restrictions right to the bottom of the vessel. This eliminates the possibility of reading a level for an empty tank, as shown in the example. Laser level transmitters can be installed at an angle with respect to the surface, and still provide a reliable reading. This is important when there are constraints on the mounting position of the laser level transmitter, for example, a central feeder. Radar and ultrasonic level transmitters must be mounted perpendicular to the surface to provide a reliable reading. When an obstacle falls into the beam, for example a rock dropping from a conveyor into a feed chute, then a short reading will occur indicating that the vessel is fuller than it really is. The laser level transmitter is able to reject these short readings using software filters that keep the level reading stable. A further capability of the laser level transmitter is that under conditions where more than one return signal may be present, such as when looking down through a grating, the instrument automatically measures to the last bounce. This last bounce detection allows the laser level transmitter to look through glass windows, past small structures, and down to the solid surface below. Last bounce detection also allows the laser level transmitter to look through fog or dust down to the surface below. However, last bounce detection will not allow the level of clear liquids to be measured. The level measured will be the bottom of the vessel. As long as the laser level transmitter is perpendicular to the surface and the liquid has some color, there will be a reflection and a reading. Radar level transmitters are dependent on the dielectric constant of the liquid or solid to be measured. If the dielectric constant is too low, there will be no reflection and the radar reads the bottom of the tank. Therefore, radar works great for water, but not for many organic chemicals. The laser level transmitter software has been developed with a smart filtering option. This algorithm allows one to ignore a signal that bounces off a stray rock or dust, but keeps the true signal that arrives last. The laser level transmitter can be installed on top of tanks with obstructions such as agitators, grids, and pumps, and is still able to provide reliable readings despite the continuous movement. The use of light from the laser in the laser level transmitter makes evaluating possible applications easy. The human eye is sensitive to light in the same way that the optical detector of the laser level transmitter detects the return pulse. This means that if you can clearly see the granular solid surface, then the laser level transmitter should be able to measure its level. Now let's summarize this learning module. So, what have you learned so far? The laser level transmitter works by measuring the time of flight of a laser pulse to the surface and back again. The laser level transmitter has a number of technological capabilities that make it well suited to measuring level. These technological advantages include having a narrow measuring beam, getting no false signals from the surface being measured, an ability to ignore intermittent obstacles using rock rejection, last signal detection, and it's easy to identify applications by looking at the surface to be measured. Have you understood